Hi friends, this is about turbofan engine. This turbofan engine is similar like turbojet engines. So let us see how this engine is working and how this engine is efficient than other engines. So yes, okay. So let us see the arrangement of the turbofan engine. So in the case of turbofan engine, we have a compressor, turbine, and a combustion chamber, and we have a fan. In addition to this all, we have a fan. So in the case of turbojet, what happens? We used to have a compressor, combustion chamber, and turbine. So and then we will have a nozzle. So here, in addition to that, we are having a fan. This fan is very much important because this fan only splits the air, splits the incoming air, so into two parts. So one is the cold air, another one is hot air. So this hot air is called primary air, and the cold air is nothing but secondary air. So the hot air only mainly travels through the compressor, combustion chamber, turbine, and then finally it comes through the nozzle. And then cold air mainly travels through the passage called bypass. That is nothing but the outer covering, that the passage exists in the outer covering of the main engine. So through this passage, the secondary air is traveling, and then finally it comes and mixes with the hot air in the nozzle, and then to produce the thrust. So that is how the thrust is produced. The thrust produced by the turbofan engine is a combination of two. That is nothing but thrust produced by the cold jet, and thrust produced by the hot jet. So we can just say that total thrust is nothing but thrust produced by the cold jet plus thrust produced by the hot jet. So this is one thing. Okay. So and next thing is the fuel flow rate is changed in the turbofan engines because of the addition of fan. So because the fan slightly changes the fuel flow rate, and so what we can say slightly increases the fuel flow rate. The increase in the fuel flow rate is affected in the increase in the thrust. So the thrust produced by the turbofan engine is much higher than the thrust produced by the turbojet engine. So that is one thing we need to note down. And because of the increase in fuel flow rate, so what happened? It is producing the higher thrust. So that is we can say that it is fuel efficient. That means this engine is efficient than other engines. So or the efficiency of the turbofan engine is higher than the other engines. And other thing is this engine is having one thing called bypass ratio. So we say it is bypass ratio is nothing but it is the ratio of mass flow rate of the cold air divided by mass flow rate of the hot air. So we just so this is what we say bypass ratio. It means bypass ratio will be always greater than 1. So for example, if you say bypass ratio is 3 is greater than 3, then or bypass ratio is equal to 3, it means the mass flow rate of the cold air is 3 times that of mass flow rate of the hot air. So that is the understanding. So this is yes, and then this engine has less noise. This engine is less noise. Uh, so because of the mixing, that means the cold air and the hot air mixes in the nozzle. So because of the mixing of this cold air and hot air, so what happened, this engine produces less noise. So that is one thing we need to note down. So yeah, so this engine is more efficient, and also more, that means higher thrust, and especially higher takeoff thrust, we can say. So in this engine produces higher takeoff thrust, uh, higher takeoff thrust, and then it has the less noise. So three advantages, mainly because of the fan, and especially this engine is what to say, the frontal area of the engine will be larger because of the fan. So that is only the just we can say restriction or limitations. The frontal area is higher than other engines, that because of the fan. So other than that, this engine is more efficient, more what we can say fuel efficient, and also higher takeoff thrust, and also it has the less noise.